got one note card today. And this is number 79. Title is Proving that a Quadrilateral is a Parallelogram. Proving that a quadrilateral is a parallelogram. So today, the questions are going to be asking, is this a parallelogram? That's different than yesterday, because yesterday, the directions told you up front that you had a parallelogram. So just to review, yesterday they told you, it's a parallelogram. What happens when you know it's a parallelogram? Like, there's some things that happen. Yeah. So for one thing, they have parallel sides. That's why it's called a parallelogram, right? So what she's saying is that if you know you have a parallelogram, then this side is parallel to this side, and this side is parallel to this side. Okay? What else happens when you have a parallelogram? Yeah.
The two angles on one side of the parallelogram.
So the angles that are next to each other, they're called consecutive angles, are supplementary. Good. So that means they add up to 180. What else happens on a parallelogram? Mm-hmm. Opposite angles are congruent. So this angle is 80, then this one's going to be 80 also. If this one is 55, this one's going to be 55 also. Yep, last but not least. Oh yeah, sorry, there's two more things. Good, the diagonals bisect each other on a parallelogram. So the diagonals cut each other in half. And then finally, the opposite sides are congruent. Okay, so yesterday we said, here's what a parallelogram is, and if you know it's a parallelogram, there's a bunch of other things that happen. And so we were just working problems based on knowing that it was a parallelogram. But today we're going to switch that around, and the question's going to say, is it a parallelogram? All right, so first fact says that if both pair of opposite sides of a quadrilateral are congruent, if both pair of opposite sides of a quadrilateral are congruent. So go off to the side here, just draw a quick sketch. So let's say you have a ruler and you measure this and it turns out to be 4 inches. And then you measure this and it turns out to be 4 inches. So that's one pair of opposite sides congruent. And then you measure this and it comes out to 7 inches. And you measure that and it comes out to 7 inches. So now that's 2 pair of opposite sides congruent. So it turns out that if that happened, this would be a parallelogram. I know it doesn't look like it, but We're going by the facts, not by the appearance.
Mr. Early,
Yes. Yes.
you have Alex Schmitz.
Yes.
Send her to the attendance office. She's leaving.
Okay.
Thank you.
It's really easy to talk over that thing. You can tell what people are saying. Okay, so anyway, so here's two pair of opposite sides that are congruent. And that's enough to prove that it's a parallelogram, it turns out. So that's what this first idea here says. If both pair of opposite sides of a quadrilateral are congruent, then it is a parallelogram. So if you're investigating, trying to figure out if a figure is a parallelogram, one way to figure it out is to measure the sides and see if the opposite sides are congruent. Okay, but maybe you lost your ruler, but you have your protractor, because you would never lose that, because it's such a dear tool to you, because you love your protractor. So you lost your ruler, but you've still got your protractor. So you instead are going to measure the angles. So here's another idea, and it says, if both pair of opposite angles are congruent. If both pair of opposite angles are congruent. So you've got this figure over here, but you don't have a ruler, so you can't measure the sides. So instead, you measure the angles, and maybe you measure this one, and it comes out to 100 degrees. And then you measure this one, and it comes out to 100 degrees. So you've got one pair of opposite angles congruent. And then you measure this one, and it comes out to 80. And you measure that one, and it comes out to 80. And so now we have two pair of opposite angles congruent. Then that would be enough to prove that it was a parallelogram. So if both pair of opposite angles are congruent, then it's a parallelogram also. Okay, another possibility is if the diagonals bisect each other. Then it's a parallelogram. If the diagonals bisect each other, then it's a parallelogram. So that means both diagonals are cut in half by each other. So this one and this one cut each other in half. If that happens, then that's enough to prove it's a parallelogram. And then finally, if one pair of opposite sides is both parallel and congruent, if one pair of opposite sides is both parallel and congruent, then it's a parallelogram. That's the punchline today. So the questions are going to say, today are going to say, is this a parallelogram? And here's 4 different ways to tell. That's what that note card is about. There's a whole bunch for you. Of course, you need a sheet of paper. Title today is Geometry 6-2. Let's start with number 2. Do not need to draw this picture. We can just all look at it up here. So we've got a 4-sided figure. There it is. Then we have this extra line coming off of it. And the question says, is this quadrilateral a parallelogram? And then if it is, explain how you know. So is this a parallelogram? Turns out it is. Okay, so we got to figure out how we know. It's a little bit awkward, right? Because there's that missing angle that they didn't tell us. Is there any way we can figure out how big that angle is? Yeah. Yeah, these two right here, that's a half rotation, right? So it's 180. The fancy way to say it is these two are a linear pair, so they're supplementary. So to figure out this angle, you just take 180 minus 118. And that comes out to 62. Okay, so now we figured out that that's 62. They didn't tell us up front, but it was pretty easy to figure out it was 62. Okay, so then how do we know that this is a parallelogram? Yeah, Charlie? Both pair of opposite angles are congruent. Awesome. The 62 is matching up with the 62. And the 118 is matching up to 118. Okay, so this is a parallelogram. The answer is yes. And the reason why is because both pair of opposite angles, I'm abbreviating a little bit there, opposite and then angles are congruent. And according to this theorem over here, if both pair of opposite angles are congruent, then it's a parallelogram for sure. So we're just using that fact there. Okay. Here's number 5. This one does not look like a parallelogram, but we can't go by appearances. We have to go by the facts. And they have a tick mark there and a tick mark there. So again, that's kind of strange. They're saying that this side is the same length as this side when they put tick marks there. Doesn't look like it, but that's what the facts are. Okay, then there's a heavy arrow here. And there's a heavy arrow here. What do the heavy arrows mean? Yeah. It means that that line is parallel to that line. Okay, so we have some information about this side and this side. They're congruent and they're parallel. So, is it a parallelogram? Yeah, it is, because according to this theorem here, if one pair of opposite sides is both parallel and congruent, then it's a parallelogram. So yes, it is a parallelogram because one pair of opposite sides is both parallel and congruent. So here's another figure that doesn't look like a parallelogram, but we are going to go by the facts instead. This is written as m equals 3, and m stands for the slope. Remember y equals mx plus b? The m is the slope. So that means that the slope of this line is 3. And then the slope of this line is also 3. So what happens if two lines have the same slant to them? If they have the same slope? Then they're going to be parallel, right? Okay, so this side is parallel to that side. So if I wanted to, I could now put heavy arrows there, because I know the slopes are equal, so that means they're parallel. And then this slope is -1, and this slope is also -1. So that means that this side is parallel to that side, because they have the same slope. So is this a parallelogram? Yes, because both pair of opposite sides are parallel. And that's the definition of a parallelogram. Okay, number 6, we've got a couple of points to plot. So just draw an x-axis and a y-axis. Y-axis, x-axis. The first one is -1, 6. That's point A. Then B is 2, -3. C is 5, 2. D is 4, 9. All right, so we have this four-sided figure, and we're trying to figure out if it's a parallelogram. That's the question of the day. Yesterday they told us up front that things were parallelograms. That was nicer because then we knew stuff. Today we don't know a lot. We're trying to figure out if it's a parallelogram. It certainly doesn't look like it, but we can't go by appearances. We have to go by the facts. All right, so one thing that's true about parallelograms is that the lengths are equal. This length needs to be equal to this length. So how could I figure out this length? I mean, if I had a ruler, I could measure it, right? But there's a different way. How can I figure out the length there? Yes? Yes, it's called the distance formula. Good. So We've been using this formula for most of the year. It's kind of a pain. So what you do is you take 9 minus 6 and then square it. And then plus. And then 4 minus negative 1 and square it. So what I'm doing here is I'm finding out how far apart A and D are. Finding the distance or the length between A and B. So 9 minus 6 comes out to 3. 4 minus negative 1 comes out to 5. And 3 squared is 9. 5 squared is 25. 9 plus 25 is 34. And square root both sides. You could go ahead and take the square root of 34, but it's a big, nasty decimal. I think it's around 5.7. I'm just guessing. Better to leave this then, because then you don't have to round. So that means that if you had a ruler and you measured from there to there, it would be 5.7 centimeters, or 7. All right, so if this is going to be a parallelogram, then this length needs to be the same. Because on a parallelogram, opposite sides are congruent. So I'm going to see if this length is the same. So we've got to do the distance formula one more time. So how does it start out for these 2 points? Yeah.
2 minus negative 3.
Good. So you do y minus y. 2 minus negative 3. So now we're looking at CB. We're doing 2 minus negative 3 squared and 5 minus 2 squared. Two minus negative 3 is 5. 5 minus 2 is 3. Then 5 squared is 25, and 3 squared is 9, and 25 plus 9 is 34. So you can already tell it's going to come out to the same answer, which is good news, right? Because if it's going to be a parallelogram, the opposite sides have to be congruent. So now we have this as the square root of 34, about 5.7 centimeters. This is the square root of 34. So far things are looking pretty good. If you want it to be a parallelogram. I mean, I don't know what you're rooting for here, but probably not rooting for anything. Okay, so now I'd rather not do the distance formula 2 more times because that's a pain. So at this point, I could find this distance and see if it matches up with that distance. But distance formula is a pain. So what I'd like to do instead is find out the slope of this line. Okay, so and then the other reason I'm doing that is to review the slope formula. So now I'm going to find the slope of AD. So how slanted it is. If it has a big slope, that means it's very steep. If it has a small slope, it's not very steep. Okay, the slope formula is similar to the distance formula. You still do 9 minus 6, and you still do 4 minus negative 1, but instead of squaring them and adding them, you do a fraction. So it's 9 minus 6 over 4 minus negative 1. So you still subtract the y's, 9 minus 6. You still subtract the x's, 4 minus negative 1. Except you make a fraction this time when you're doing slope. All right, so that comes out to 9 minus 6 comes out to 3. 4 minus negative 1 comes out to 5. So that means the slant is 3/5. So M slope is 3/5. So now I'm going to check out the slope of this line. And if it matches up, then I'll have one pair of sides that is both parallel and congruent. And that's enough to prove that it's a parallelogram. So let's see what the slope here is. So it's going to be 2 minus negative 3. So I'm doing the slope of CB now. So 2 minus negative 3 all over 5 minus 2. 2 minus negative 3, 5 minus 2. So that comes out to 5/3. Is that the same slope as this? No, so they're not parallel, which means it's not a parallelogram.